All right. Awesome. Let's see. So we got one person now
Is it
on.
on the YouTube streaming?
Yeah, so it's streaming on YouTube, LinkedIn, and Twitter.
Okay, awesome.
Yes. Awesome. Awesome. Yeah. So welcome everyone. I see one person eight people in the audience now. So welcome everyone. This is our third live interview that we do monthly. So if you're new to this kind of series of what we're
Mhm.
doing, it's YouTube interviews where we do interview people from the Streamlit ecosystem or people that are building with Streamlit to some extent. So today, before we even get started, I usually like to ask folks where they're watching us from. So please, on the chat, can you share where you're watching us from? I know I'm hosting from Virginia. Dr. Wu, our guest today, where you tuning in from?
I'm from Knoxville, Tennessee.
Nice, Knoxville, Knoxville. I see a lot of folks there. Hi, hi. Yeah, we do have a lot of people in the chat. I see Don Kelly, Niels, Oluwafemi, Stelio, Isaac.
Wow, it's from
Yeah,
everywhere.
yeah. See Germany, Hillary Chorus from Nairobi, Kenya, Hernan from Colombia. I see Niels from Germany, Justin Toronto, Sudansu from Boston,
Mhm.
Christian from Berlin, Oluwafemi from Nigeria, Pritash from South Africa, Johannesburg. All right, it's a lot of folks on here. Awesome.
Yeah.
Um, Stelia from Netherlands, a LinkedIn user from Florida,
Mm.
Joseph from Nigeria, Abdurrahman from Alberta, Canada, uh, Jayalakshmi from Dubai. Sorry if I'm butchering your names here. Maud from New York.
Wow, that's a long
Awesome.
list.
Yes, it is a long
Yeah.
list, and I think
Wow.
it's still flowing in. So, if I don't get to you, I'll definitely say hi to you.
Mhm.
A bunch of folks from Bogota,
Wow,
Colombia.
nice to see Martin here.
Oh, nice. Yes, you do recognize some folks.
Uh-huh.
So yeah, awesome. So keep them coming in. We'll definitely acknowledge all of you, and thank you for joining us today. So
Mhm.
just a few things to keep in mind as we continue with this live stream today. We'll definitely, if you have any questions for Dr. Wu or myself,
Mhm.
please make sure to put them comment and whatever platform you're watching us from, and we'll be able to get the questions here on our chat. See Wisdom from Kenya as well. A bunch of folks there. Mapango from South Africa. It's definitely a lot of people. I'll definitely shout out to y'all at the end, definitely. But as we get started, like I've said, make sure to comment on the section if you have any specific questions for
Mhm.
Dr. Wu or myself. Awesome. So with that said, I want to welcome our guest today. Our guest today is Dr. Qiusheng Wu, and he did mention we did go through how to pronounce his name. I probably did mess it up, but thank you, Dr. Wu,
Pretty
for,
great.
for bearing with me. Yeah, and so a bit, I'll give us a short description of who you are, and you can tell me if you're wrong, and you'll add it on later.
Mhm.
So Dr. Wu is an associate professor in the Department of Geography and Sustainability at the University of Tennessee, Knoxville. In addition, he holds positions as an Amazon visiting academic and a senior research fellow at the United Nations University. He's also the creator of several open source packages, which today we'll be talking most about it,
Mhm.
designed for advanced geospatial analysis and visualization, including GMAP, LeafMap, and Segment Geospatial. So, welcome, Dr. Wu.
Thank you for the invitation.
Yes, absolutely. So, uh, I've done a little bit of introduction of who you are. So, would you go into a bit details and tell us more about yourself?
Yeah, so right now I'm a associate professor here of doing geospatial at the University of Tennessee, and I got my PhD in geography in 2015. And so this is I finished almost 8 years working at the academia, and from tenure track assistant professor, and recently promoted to tenure professor just 2 months ago.
Oh,
And so I do teaching in geospatial, mostly doing programming, open source software development, and also some public education. So I also create packages, creating tools, making videos. Basically, makes my life easier for myself. But in the meantime,
nice.
if it benefit other people, that's great because I have to teach my student how to, utilize this geospatial technology, cloud computing. So initially, I was just building the tools for them, like makes it easy for me to teach. and looks like the community like it. And then so I post more to GitHub, and then so now my daily life is basically adding new features to those packages, answering questions from the community, and when I have time, I record the videos, just introducing those new features. So that's something that I enjoy doing. I like
Yeah.
seeing people utilize some of my open source packages and then build their own applications. And I also like love working with the community, how to make those packages, open source tools, even better. And that's one of the parts that I also appreciate those open source packages like Streamlit. That makes it
Nice.
easier for me to like make my data products accessible to other people. Because one thing I really like is that we need to lower the barrier that other people can actually try out your stuff. Otherwise, it's just on GitHub. Nobody know how to put a GitHub repo. Nobody how to actually spin up a server. And,
Yes.
and packages like Streamlit, Solara, and other web mapping framework. It makes my life so much easier.
Oh, nice.
Yeah,
That's
thank you.
good. Yeah, definitely. That's great to hear that Streamer does make your work easier,
Mhm,
and I love the fact that you're building solutions for yourself, but you
mhm,
end up building solutions for other people as well.
mhm.
So that's the power of open source.
Yeah,
And also, I want to acknowledge and congratulate you for your recent promotion. So
thank you.
congratulations.
Uh,
Yeah, absolutely. So just as we get started here,
mhm,
for me as well, and also I'm sure some part of our audience as well, you know, we know probably we've heard about geosciences,
mhm,
but why is it important and why
mhm.
should we care about it?
Yeah, of course. I mean, we use geospatial technology or geospatial data all the time, but people usually are not realizing that they're using that. So one simple example: if you use Google Map, Google Earth, Apple Map, whatever, or even Uber, Lyft, right? You're taking a ride.
Yeah,
Those are, I mean, behind the scene is dealing with tons of geospatial data. So anything that you're dealing with, location, your phone, for example, checking your
yeah,
daily activities all the time, your location, and behind the scene they run all kind of analytics to figure out where are you going, where are you shopping, and then what things you buy, what location you visit, right? Those are tons of like business opportunities. So most of the companies or government agencies, they're utilizing those geospatial data to analyze patterns and over, for example, disaster management, right? So if
yeah,
something happened, for example, earthquake in Morocco or flooding in Libya or whatever, like you need some of those geospatial data to help you make informed decisions, because sometimes those locations are not accessible anymore. So without a satellite, you cannot actually see what's going on. So with those satellite data and also lots of like open geospatial data, people can be more aware of what is going on and what's going to happen and how do you mitigate the damage, something like that. So with that, if you have that kind of skills, you're going to make way more informed decision. Or even maybe a more real life example. You're trying to buy a house, right?
yeah,
I mean, location is very important. Or you're trying to rent an apartment, right? Where do you
yeah,
rent, right? How is it convenient? What are the nearby school? What are the crime rate, right? Those are all dealing with geospatial. So I'm 100% sure if you are a human being on Earth, you are interacting with some geospatial stuff, but you just may not realize you are doing that.
yeah,
And so that's what my mission is, to actually increase the awareness of this geospatial data, geospatial technology, or even cloud computing, and utilize these free resources and to make your life easier and
yeah.
to make some money or save money.
Yes, absolutely, absolutely. So you bring up a good point there. So it's interesting how you mentioned that we do use these technologies,
Mhm,
but it's super abstracted away on what's
mhm,
happening on the back end for the
mhm.
users. We just kind of see scroll our phones
Yeah.
mindlessly without, but looking underneath the hood of which you kind of do
Mhm,
most of the time. This is like interesting stuff as well.
mhm,
So. Uh, with that as well, I know your focus mostly is on wetland inundation
mhm,
systems, which is quite intriguing, and I don't really
mhm,
fully understand what that
mhm.
means. So, could you take a moment to explain to us what that means?
Yeah, so kind of like, so like, for example, if you're trying to monitor how the environment is changing, right? We use a lot of geospatial data. So for my specific area, I'm focusing on mapping surface water, because surface water is very dynamic. It's
Yeah,
based on those smaller water bodies, right? During the dry year, during the wet year, basically the water body actually changes throughout the year, throughout the
yeah,
season, and how do we actually keep track of those? If you just go to, for example, use Google Map or Apple Map, whatever, right? It's only a one time. It's just like one
Yeah.
time snapshot. But things are changing all the time throughout the season, and how can actually monitor the changes and figure out like how fast it is changing, or
Yeah.
is it totally drying out like after a couple of years, or is it getting much wetter, and how do they actually contribute, for example, to flooding? Because if you have a large water pond somewhere like in the upstream, if that one
Yeah.
is gone, like the water is going to come directly to the downstream. So how do you figure out when it's going to cause flooding, and how severe the flooding is? So with those kind of information, you'll be going to make um, life easier for other people, so they have a better idea of what's going on in the environment and when do you need to take actions, either to protect those wetlands or surface water bodies, something like that.
Oh, nice. Yeah, that
Mm.
so many use cases there for even disaster management and farming as well. Yeah, that's very interesting with what you work there.
Let me
And
move around. You
okay,
sit for too long, so the light is off. Okay.
all right,
Uh,
some sensors.
uh,
Wait,
uh,
yeah, but awesome. So with I saw some really interesting work you did not so long ago with the disaster in
mm,
Morocco. I
mm,
saw you posting a lot about like the
mm,
mapping, and
mm,
I think that was kind of like the first interesting kind of look
mm,
into kind of mapping where the disaster zone is happening and things like that. So
mm.
um, yeah, so with that as well, I think it kind of maybe I can let you touch a bit on that aspect because I saw you posting a lot about that.
Yeah, so the reason that I did it was because I mean, those companies they release the data. We have a lot of data in the public domain. For example, Landsat Sentinel by NASA, by European Space Agency. So those data are usually freely accessible, but the resolution is a little bit coarse. So basically, you cannot see the detail of all individual buildings. And there are also commercial companies that, for example, MaxR or Planet, that release data a much high resolution.
Yeah.
And some of those data, when some disaster happen, they release so-called open data that people can have access. But like I said, those are not the regular like photo you see on Google Earth, because
Yeah.
it's more like geospatial data format. You will need some expertise to be able to visualize those data. And we have actually a lot of those data in the cloud, but not everyone like know how to access the data, how to visualize the data.
Yes.
So part of those apps that the goal is to make it easier for anyone to utilize. So if we can have internet access, if you can open a browser, I mean, you should be able to do that, right? Rather than you have to do the coding and to figure out what software do you use, or where the data is being hosted. So the analogy would be like you're trying to watch a movie.
Yes.
You probably don't care where the movie is being hosted or which like movie streaming services you going to use, right? There are tons of those. Your
Yes.
goal is just watch a movie. So my goal is like, oh, I just want to see the data. I just want to see how it's changing, right? So you don't care where the data being hosted in the cloud. So some of those web apps is to lower the barrier. That you just go to this URL, you click a few buttons, and then you can see the data. You can make some changes. You can visualize that. So just to make it as easy as possible, so that people can mm, as long as they have internet, they can see it. They can do it on your cell phone, on your tablet or laptop or whatever, right? It doesn't matter. So it's just trying to make it easier. We have the technology, but uh, we don't have those like very easy to use. I don't know. I mean, ideally, those tech companies should not only provide the data, but also provide those web portal that makes it easy to use. But it's not always the case. So my goal was just to make things easier. I'm not doing any groundbreaking stuff. I'm just like connecting the dots and then see if you can make it a little bit easier, and
Yes.
then it's going to reach a much wider audience rather than people have to, okay, I need to install this package, I need to install this software, and they may not support all the platforms. Like
Yes.
it's very specific. But if it is web based, just like Streamlit, right? It's so
Yes.
easy. Under the hood, you can do a lot of like pull in the database, or you can get whatever data and then just visualize that, right? So anyone can use. So it take a lot away a lot of those heavy lifting, and it makes it easy for the developer. And for me as a developer, I want to make things easier for the end users, so they don't need to like write a lot, many lines of code in order to do some simple stuff.
Yeah, absolutely. I
Mm,
think, yeah, making it easy for folks, that's always the best thing, taking out
mm,
the complexities. So I know you've mentioned, you've used Streamlit, and
mhm,
do you have an example of a project or an app that
mhm.
you used Streamlit, where Streamlit kind of played a crucial role in your app?
Yeah. So one app that I created was called like time lapse. Right. You use Streamlit to pull satellite data, create some simple animation, and that one I think was quite popular. I did it initially 1 or 2 years ago, and it's
Okay.
still running. So people are visiting the website all the time, creating animations. If you want, I can show you
Yes.
the screen. Okay, and let me see here, window, Chrome tab, Home Labs.
Yes.
Can you see my
Awesome.
screen?
Yes, we can share. There you go.
So it will be something like this. For the audience, if you like, just search Streamlit Geospatial on Google. You should be able to find all my apps and all the source code. Everything is open source, and this is one of the most popular one that I created. It basically allows you to create animation using a lot of satellite data. Under the hood, using Gmap and Google Engine. So Gmap is a package that I created for doing interactive mapping with Google Engine. So you can check out the links in here, and it's pretty very easy to use. You also have the, for example, the demo in here, if you want. So this is on from the YouTube demo. All you need is to
Nice.
basically zoom to anywhere you like, and then simply draw a rectangle or a polygon, and then just select whatever satellite you want, different band combination, and then you can just adjust some parameters. Then you should be able to create animation for you. So within 20-30 seconds, then you get the animation in GIF format or MP4. Then you can download it to your computer. So this simple example here just show you, for example, how the river dynamics, and that's kind of things that I mentioned earlier, like the surface water, the dynamics is changing all the time throughout the year, throughout
Yes.
the decades, and how to actually monitor them rather than like most of the map you see online. It's just one snapshot, but it might not be the most up to date. And you can just upload any hour you like and then just select. So, for example, this is another example of. Can you still see it?
Yes.
The, for example, like the Hong Kong airport, right? So we have
Yes.
data every year, and you can easily see the changes of the landscape. So this is the longest satellite data archive that we have since 1980s and up to right now. So every 2 weeks, for example, you get one imagery. So we get data, global coverage almost every 2 weeks, and we have more and more satellites. So now you can even get like weekly data, and also here you can see you can download it as an MP4, something like that. So pretty
Nice.
easy to do. You can do that for any location, so it doesn't really matter. And the nice thing is that it's just simple. Find your location you like, and then you can create easily. Before like cloud computing, like this take you hours or even days just to create. You might look so simple, but you can imagine like remote sensing, low satellites, sometimes affected by cloud. So you might not always get like cloud-free imagery. So you have to basically every year you're dealing with maybe 10, 20 images, and you're trying to create the best one without cloud. And then you want to download all of them like for multiple years, for decades. It's going to take a lot of data storage and also do data processing, removing the cloud, and get a better version of the animation. But now, 20-30 seconds, right? No coding, nothing. It's just automated. So if you're interesting, you can also look at the source code, for example, on GitHub. It's open source, so you can try out, for example, and show you the pages. And then, so the second one, the first one, right?
Yeah.
It's Bandit who is using Streamlit and Gmap, but you can take a look at that, right? So I wrote like thousands lines of code just to create like simple web app, but now everyone can go online. They don't have to like do the coding themselves, and it's just so much easier. It's not just for Landsat. You can use tons of other satellite data. Maybe I can show you another one here. For example, vegetation. They
Yes.
say, okay, I'm interested in studying vegetation, how the vegetation changes. You can draw a rectangle, or you can just select a sample area. For example, I'm gonna look at the vegetation changes in Africa, for example. And
Okay.
then usually you can just use the default settings. You should be able to create those animations. So under the hood is going to the cloud and to pull all the data in, and then do some data processing, and then download the data based on the visualization criteria. Take a look, right?
Nice.
Within 20 seconds, you see something like this. This you won't be able to like do that like on the ground because it's
Yeah.
like longer time scale, and you can clearly see like how the vegetation is changing throughout the season. It's quite interesting. Just like
Yes.
the nature is life. It's like
Yes.
human, just ranging like it's changing throughout the season. Not just vegetation. You can do um, even, for example, hurricanes, volcanoes. There are all kind of things you can capture. So satellite has a variety of like spatial resolution and temporal resolution. It's up to you what you want. Let me show you another one. Maybe the Go satellite. So this
Yeah.
one is like oops, no, here is very high temporal frequency. So you can get data, for example, every couple minutes rather than every 2 weeks. So it depends on basically depends on your specific requirement. You can select the satellite data suitable for your application. And then for specific data, so for example, this is the volcano eruption. This one has a lot more data because you have data for every 5 minutes. And if you want to capture
Oh,
something that happen very quickly, then you will need some of this data. Um, Take a look, right? And now
nice.
you see the volcano eruption like in Tonga, I think last year, January last year, right? And
Nice.
so much easier to use. I mean, again, it depends on what things you're interested in. It can be hurricanes, it can be volcano, it can be even earthquake or anything. As long as on the Earth surface, it can be captured by satellite. Low satellite data usually in the public domain, you can do it. So, and this is one of the things that I mean, you see on the social media, on TV, look at those animations. So now you can create one by yourself. As long as you
Yeah.
know when it happens, how long did it last? You can just go to the web app, zoom to the location, and then you can simply do something like this pretty easily. And there are a lot of things to customize. If you really want like um, very precise about the things that you want, you can do the coding. So I also have like if you go to, for example, if you check um, Gmap, like the book that I wrote about Google Sensing, Gmap, and also Streamlit. There's actually a chapter here teach you how to build those web apps, for example, using Voila, Streamlit, Solara, right? So there are different applications. You can just follow, it's pretty easy, and then you can just build a web app, and then so anyone can use it to do visualization. And specifically for creating time lapse, I have a whole chapter teach you under the hood like what kind of it's only a couple lines code. Then you can use it to create animation for any satellite you want, for any temporal frequency, and so much easier nowadays with this kind of cloud. And also, for example, with Streamlit web app. So if you don't want to coding, you can just use the web app. So pretty easy to do. Yeah, so that's what I want to show you. And there are a lot more applications. You're welcome to check out my um, GitHub repo. There are tons of other repo in here. Also template, so you can use the packages or you can use some of those template web app in here. Streamlit, Solara, Voila. All you need is just maybe clone the repo and then deploy on the Streamlit cloud or any other cloud provider that you want, and your apps will be up and running in a couple minutes. Yeah,
Yeah.
that's what I want to show you. Yeah.
Yeah, absolutely. These are mind-blowingly
Uh,
interesting. The demo you just gave us,
mm,
that's interesting. How regular folks like me as well,
mm,
that I see these apps mostly or these applications being posted on social
mm,
media. For example, when disaster happens, you see these
mm,
videos or clips from
mm,
the media showing you this animations.
mm,
And it's very interesting to see that anybody can just go there and go
mm,
to your repo and see the code, learn how to build it themselves, and they
mm,
can build this with Streamlit as well.
mm,
And also they can deploy it and have like a full app that they can actually share with their community or for work as
mm,
well. So this is pretty interesting. So during the development of this, and I think we've shared resources there as
mm,
well. And you can see on the jumbotron going underneath here,
mm,
you can see the links there for Dr. Wu's book,
mm,
which has a chapter on
mm,
Streamlit, like he's mentioned. And we'll share some more resources as well in our comments after
mm,
the show. So during the development of that app, for example, right?
mm.
And did you run into any issues with kind of integrating Streamlit with your open source projects or your open source packages?
I think Streamlit already makes it so much easier. So I mean, before I use Streamlit, I use Voila. Voila is great. You can turn the web app directly from a notebook to a web app, but it's quite limited because the interface and also is Streamlit looks a lot more modern, and it's so much easier to use because you write the components and then it's available and then you can run. So and they also can deploy to the Streamlit cloud. That's like one click, and then you can just use Google push to GitHub. It automatically like pull the updates. And I mean,
Yes.
that's kind of game changer for me. It's like okay, now I can focus on writing the functionality rather than having to maintain a server and do other type of stuff. And it's great, right? And it keep improving a lot of new components,
Yes.
and it's just getting better and better. And I enjoy seeing all the new features being pushed out, like the feedback from the community. It gets adopted and then released. It was nice. And in terms of the geospatial, the mapping components, like you have uh, PyTech and also other Folium, for example, kind of supported. Um, so you can easily use some of the packages to turn things into a web component, and then you can do mapping. So I think the easiest one probably is Folium. PyTech also officially supported. The only limitation is that sometimes when you are for geospatial, if you're just going to show the data layer, they allow, for example, for the time lapse that I showed you earlier, it's perfectly
Yes.
fine. But if you have some very complicated user case that you have to click on the map and then grab some of the coordinates and then do computation, that's kind of right now the limitation of those mapping libraries, even PyDeck or Folium that cannot do. It's more like just one-way street for displaying. And if you
Okay.
need like bidirectional, then you need some other packages, for example, like Solara, or even like Voila, they can do it. But both of them has their pros and cons, right? It's up to you what you want. And
Yes.
I kind of use both. I use whatever they make my life easier. So I kind
Yes.
of use a combination of both sometimes. And it's great, right? We have some options and you can choose from what base suited for your application.
Yes, absolutely,
Mm,
absolutely, and thank you for that feedback as
mm,
well. And so I guess I would guess your favorite kind of or
mm,
particular feature in Streamlit that you like is Folium and
mm,
PyDeck, right? Or
mm.
is that right?
Yeah, I use them both, right? So Folium is more like you turn it into HTML, but Folium is the easiest to use. But again, it's not very modern compared if you need to do PyDeck, do some 3D. I mean, sometimes you need to use PyDeck, but PyDeck is a bit more complicated to use compared to Folium. So if like more advanced user cases, you might want to use PyDeck if you know how to do the coding. For easiest one, you just want to create a map or design, visualize some, I mean, base map, then Folium is perfectly fine because it has a lot of user base in the community and it's quite feature rich. But again, it's limited because the lack of bidirectional functionality.
Nice, great. So
Mm,
with I know you created a GMap and
mm,
for and you just want you to kind of go over them
mm,
just pretty quickly. GMap and Leaf Map. What
mhm.
are the differences between those two?
So Gmap is I started like March 2020, like 3 years and a half ago.
Okay.
Initially, I was just trying to do cloud computing with Google Sending, and so the web app that I show you, the timeless, is basically pulling the data catalog from Google Sending data catalog, and then doing the computation in the cloud. And then so Gmap basically is just to make it easier for you to visualize the data and also analyze the data with just coupled code. So it being on top of the Google Sending compute API, but we use a lot of mapping libraries, for example, IPyLeaflet, Folium, and then or even Streamlit to make it easier for people to interact with the data. LeafMap is like kind of a project spin-off Gmap because um, in the past, if you want to use Gmap for commercial, you can do that. But I mean, Google Engine, if you use it for commercial, then you need to have a license. So some
Yes.
of the users they say, "Oh, I really like it, but I cannot buy the license. I still want this mapping interactive functionality." So and then I kind of okay, maybe I can take some of the components that does not rely on Google Engine, but you can use in other platform, for example, any Jupyter, Microsoft friendly computer, or even AWS, right? You can use it
Yes.
anywhere you like as long as it's like Jupyter environment. So I take out the functionality and then create a leaf map. And so leaf map basically is also open source MIT license, so you can do whatever you want. But it has a lot of commonality. The only downside is that leaf map is more like for visualization. If you need to do computation, then you need to write code to actually support the computation.
Okay.
Gmap, because it uses the Google Engine compute API, so user can do things very quickly with a coupled code. You can do a lot of complicated analysis. But
Okay.
both of them has the pros and cons. It's up to your user case. If you use Google Engine, yeah, Gmap is probably the easiest to use, and Gmap is already officially adopted by Google Earth Engine. So it's only official documentation. So if you use Google
Oh,
Engine,
nice.
then GMA probably is the easiest one to get started. But if you use other cloud computing services, and also, for example, you want to create some map and then you want to use with, for example, Streamlit, then just use LeafMap and just one line of code, and then just you can turn that one into a Streamlit component and you can display. So it saves you a lot of time, and you can do all kind of vector data, raster data visualization, and do some animation. So check out the website leafmap.org. You'll be able to find tons of notebook examples for that.
Awesome. Awesome. Yeah, definitely. I hope everybody's taking notes of that and taking a look at it. So with that as well, you've covered some good ground here, and just kind of to wrap it in a way that folks can take away today is, you can go to Streamlit or go to those applications that or those packages that Dr. Wu has created and look at the GitHub, play around with it. You can create a Streamlit app and basically deploy it to Streamlit Community Cloud for free if it's in a public repository, and you can deploy as many times as you want. And the only limit is just that 1 gigabyte of memory that you have RAM for your apps. So feel free today to just kind of go on Streamlit and build these apps and deploy it out there so that people can interact with. And also, as we close out, from the audience, I would like for you to type in questions, send us some questions on the chat, and let us know so that I can ask Dr. Wu here, because that was a pretty interesting demonstration that you did today. So definitely like to hear from you any questions that anybody has on the chat. Open to it. And while we wait for folks to ask questions, I want to learn from you a bit more. With the advent of AI right now, and from your viewpoint, from a vantage point, from educational standpoint, where do you see kind of geospatial sciences going with AI?
I'm not good at prediction, but just based on my experiences using all these satellite data, open data, and also some of the recent AI. So certainly AI is going to play a big role in the geospatial domain. And one simple example would be like we have tons more data coming in from satellite, commercial. How do we actually make it easier for more accessible and also easier to do analytics on those, right? Just like some of those recent natural disaster examples, right? We have data, is something happening, we have the data, and then the data might take maybe a day or a couple of days to get the data. And then after that, like, what do we do with the data, right? Do we have the latest algorithm to like run the data, get the result? For example, all the buildings were destructed. We're trying to figure out how many buildings are destroyed. And that's actually not like trivial. It's actually takes time. And even for tech companies, like it took them a couple of days to be able to analyze the data, process, and release the result. So I'm hoping that in the future, once with this all AI and foundation models get into everybody's hands, you can just go online, you can pick the data you want, and if something happens, we get the result within like 24 hours. So really fast response to those disasters. It can certainly save a lot of money and people's life, because if you can respond quickly and know what's going on, what should we prioritize resources, how should we prioritize the resources to those disaster recovery, then we certainly be better. But for now, it's getting better. We are getting there. But I'm hoping that with this OAI, it will make things a little bit faster. And for some of the packages that are created, also try to address some of those issues. For example, the segment geospatial, like just give a satellite imagery, I can segment that one for you. So build on top of the segment image model. But hopefully in the future, we can have more like not just the segmentation. You can also do classification, like we can keep monitoring what is going on, and we can figure out what has changed and how is it going, right? So there are tons of things you can do in geospatial with this open access data and also AI or Geo AI. You can follow the GitHub repo. I create a package called Geo AI. So my goal is to implement some of those functionalities and makes it easier for people to utilize this technology. So ideally, just give an imagery, give some data, training data, or whatever. One line of code, okay, give you the result. That'll be easier because not everyone know how to like put up the deep learning model and then just run with GPU. It's kind of complicated. So I'm hoping that I can create those packages to make it easier for people to utilize data and also all these free cloud computing resources.
Okay, awesome. Yeah, I think you did a pretty good job there with your prediction. I know it's really hard to predict, but those are some good bold predictions. And so I'll see some few questions there. So
Sure.
yeah, I'll put them on the screen, and then we'll
Mhm.
cover them once we go. So I think we got a question from Christian, sorry. How would you optimize for speed, caching, and also process somewhere else? I think. Let me see her question. I think she probably clarified the question underneath here.
Yeah, so that one, it depends on what you want, right? So
Yeah.
if you're using some of those cloud computing resources, some of those actually being handled. For example, if you use Google Sending, like they already handle those like speed and large computation pretty easy. But if you're doing like having your own server, you run things locally, then you certainly need to optimize the speed, use some database. And I think one thing that I really like recently is like DuckDB allows you to handle like gigabyte of data within seconds or minutes, right? So you can see some of the latest development in the community, say how people are doing that. And they also some like in Geospatial looked about open data format, cloud optimized GOT, spatial tempo S catalog, vector data, PM types. Like there are a lot of new things coming out, and just following the community, see how people are doing, or just follow me on Twitter. You will see some of the latest one. Like I'm trying to actually adopt some of those latest technology and then make it easier for people to utilize that. But there are a lot of people on the community. If you go on Twitter, the geospatial community is quite active. And if you have any questions, just ask people. We'll be able to maybe give you some suggestions.
Yeah, absolutely.
Mm.
And we have another question here
Mm.
from Jose. Yep. His question is: sometimes I cannot decide Streamlit or Gradio. Any
Mm.
advice? Do you have any advice for him? Because I know you've used both.
Yeah, I use both. I mean, Streamlit is by Streamlit, Gradio is by Hugging Face. So they kind of serve similar purposes. To me, in terms of geospatial, they are kind of similar because they both like use Folium. But it's up to you what you want. But to me, I mean, Hugging Face also supports Streamlit. So if you develop Streamlit, you can deploy it to cloud, Streamlit cloud, or you can directly deploy it to Hugging Face. So in general, Hugging Face has a larger user community because it has a longer history and it's more feature rich. In just my personal opinion, not to just any company, but yeah, I think Streamlit is easier to relatively easier to use. But to me, it doesn't matter. All you need is just to get things done, and whatever works for you, you things find easier. Just do it really well, and you can either do Streamlit or even do radio, and then if it's not good enough, yeah, contribute to those packages, make it better, and eventually, um, but it's great to have options, like not just one, because sometimes you only one option. If something goes away, then people will be like very worried. But choose whatever works for you best, and then
Yes.
just stick into it, do it really well.
Yeah,
Mm.
absolutely. Good advice there. And I think you definitely covered it pretty well in terms of just kind of like use the best tool that kind of serves
Mm.
your best needs,
Mm.
but also being aware of what we have is
Mm.
great. So I think somebody else. So I think the stream here, for some reason, I'm not getting some questions from earlier. It disappeared, but one of them here from K2ICC says, "Do you Streamlit uses the GPU?" I think I can take this one.
Mm.
So we we don't re- would Stream doesn't really offer a GPU for your instance. You have 1 gigabyte of RAM
Mm.
accessible to your app that you can use, but it doesn't offer a GPU. But what you can do as well in this case, you can have a backend where you that serves you a GPU, and then you can do those computations on there, and then just kind of call it to your Streamlit app.
Mm.
For example, I think you can use something like AWS and port it over
Mm.
to your Streamlit app. You kind of
Mm.
offload that computation from Streamlit itself, and
Mm.
then just use the Streamlit for the visualization.
Mm.
Hopefully, got your question answered there. I think we had a couple of them earlier
Mm.
on, but I can't see them anymore. I
Mm.
think mostly from LinkedIn. I can't see
Mhm.
it. It's just YouTube for now. So
I
sorry
see.
for
Okay.
that. But if you did ask a question there on LinkedIn, we'll be able to go back and answer those questions on the chat
Yeah.
afterwards. Because
Yeah, just a quick follow up. There's a question about like, is the repo still accepting contributions? Yes, it's all open source. Contributions are always welcome. So just look at the repo, find anything you want to contribute, fixing bugs, typo, whatever. I'm just one man. Like I only have 24 hours, so I try my best, but I cannot do everything. So any little contribution help. You can go there. Always welcome. And if you have any questions, let me know. I'm happy to work with you to make your first contribution. I always ask if people like, oh, there's something wrong. Yeah, could you please like submit a pull request? It will make it easier for me, and also you're being recognized as contributor. So the more contributor to a report, like more like become popular. So it's like win-win situation. So please contribute.
Yes, it's Hacktoberfest. We still got a few more days, 5 or 4 more days to go. So yeah, please go on Dr. Wu's repo and contribute if you have specific things that you need to see on there as well. And you can see the repo still going underneath the jumbotron at the below. So I think for the other questions, for sure, we'll be able to answer them on LinkedIn as well, or the other platforms. So please keep them coming. And just to close out here, it's been an honor, pleasure to have you here today, Dr. Wu. It's been very informative for myself, and I also hope for the audience as well. Hopefully, you gained some valuable insights today, and for me as well. I've gained a lot of information here that I can have a starting point on it. I think I have a better understanding of geospatial sciences now, and some fond interest for it now. So, with that as well, I want to give you some time a bit to close out. A few parting shots before we close it.
Yeah, so just want to point out that if you have any question, if you have any interest in there, you can follow me on like social media, Twitter, LinkedIn, YouTube, Facebook, and I'd love to talk with you to see what you've been working with, how you utilize those latest geospatial technology. And if you want to find a career in geospatial, it's also possible. You can like just look at what people are doing in the geospatial, and if you have the skills, it's much easier to find a job that can make you make a living out of this geospatial. So again, there are tons of opportunities. There are a lot of new things are coming out and lots of new technology. I'm very excited. I mean, personally, to learn all the great open source projects that's out there. And actually, I mean, right now I have a career because I do some of those. Like and everyone can do it. It's not like secret. It's all open source. All you need is just some patience, and then have a computer and have some internet, and then just have fun, learn something new every day, and then ideally, if you can contribute back to the community. So this is how we, I mean, make it better and make stronger.
Awesome. Yeah, absolutely. That's a good call to action for folks. Get started. That's the main thing. And and for our audience, do not forget to follow us on our social media. You can follow us on LinkedIn, Twitter, and our YouTube channel as well. That way you get more updates for more of these future live events that we host as well. So without further ado, thank you, Dr. Wu, for coming on today. And thank you, the audience today, for tuning in and listening in. Please, we would love your comments and feedback in the chats of what you liked about today's show. And also, if there's any interesting folks that you would like to see in future, please suggest them for us. We welcome any suggestions. And so with that, until next time, see you and happy streamliting. Goodbye.
Thank you, everyone. Thank you for attending, and hope to connect with you on social media. And thank you, Tony, for the invitation. It was fun chatting with you, and with the audience.
Absolutely. Goodbye, everyone.
Bye bye. Take care.